Hey, this is Julie Hester, and I'm going to show you some more things about using vectors in C++. In this video, I'm going to show you how you can use multiple vectors to store related data, how you can add elements to a vector, and some simple ways you can manage a vector's capacity. Sometimes we'll use multiple same-size vectors for storing related data. Each vector holds data for a different item, and each vector has the same number of elements. Elements with the same subscript are related, so the first element in one vector is related to the first element in another vector. So some things that you might want to use this with would be if you had a vector of item names and a vector of prices for each item. Or you could have a vector of month names and a second vector with statistics for each month. Here's an example of how we can use this. I have one vector named item that stores 3 strings and a second vector named price that stores 3 doubles. The data in each of these vectors is related to the data in the other vector. So I'll begin by assigning a value to the first element in each vector. I'll use my @ function with subscript 0 to assign tacos to the first element in the item vector. I'll also use the @ function with the same subscript 0 to assign 6.99 to the price vector. Then when I access the elements in these vectors, I'll know that tacos are $6.99. I can add 2 more things to each vector, again by using the same subscript with each vector to store the related items. So I've added enchiladas and $7.99 as the second element, and for the third element in the vectors, I have salad and $7.49. Now when I want to retrieve the items in these vectors, I can use the same for loop heading as I've used to retrieve elements in one vector, where I'm starting with my iterator value at 0, and my for loop will execute until we get to the size of one of the vectors. And it doesn't really matter which vector I use here because they're the same size. Inside the for loop, then I can reference the current element in each of the vectors by saying item.at subscript I and price.at subscript I. And since I'm using my iterator variable as my subscript, I'll always be referencing the 2 related items for each of the vectors. And if this loop were to execute, I would then see tacos $6.99, enchiladas $7.99, and salad $7.49. Now sometimes when we're working with a vector, we have a need to change its size. And one way we can do that is with the resize function. I could have a vector like this one named names that holds strings. But when I created this vector, I didn't indicate the number of elements for this vector, so it's an empty vector. If I use the resize function by saying names.resize with a number in the parameter, I can now change this vector to have 5 strings in it. The resize function not only adds elements, I can use the resize function to reduce the number of elements as well. If I were to then call resize with 3, the last 2 elements would be deleted. Probably a more common way to change a vector size is by adding elements to the end. And when I do this, I'll often do it by declaring an empty vector first. I may have a situation where I just don't know how many elements I'm going to need. I could be reading a list of values from a file or some other source, and I just have no idea how large my vector needs to be, and I don't want to create the elements yet. So each time I want to store an element in this vector, I'm going to use the pushback function, and it's going to store whatever element I'm using at the very end of the vector. It looks something like this. Again, I have my string vector named names, and when I declare it here, it has 0 elements. I can use the pushback function to add 2 strings to this vector. So I'll say names dot push back, and in parentheses, the value that I want to add to the vector. So because this is a string vector, I'm going to add the string literal to this vector, or I could have a string variable. Once I'm finished adding my elements to the vector, if I wanted to see the size of the vector, I can use the size function, and I'll see that now this vector has 2 elements. So pushback is an easy way to manage your vector when you don't know how many elements you need to create. But one downside of using pushback is we can have some impacts on our vector efficiency. So whenever we're adding elements to a full vector, meaning we've already filled the array inside the vector with items and there's not space for any more elements, we can still use pushback, but our vector is going to have to allocate a bigger array. So I might have an array inside my vector with 5 elements. When I want to add a 6th element, there's not space for that element. My vector is going to have to create a new array and then copy each existing element to the new array and release the memory from the old array. If I just have a handful of elements, this isn't really a big deal. But if I'm working with lots of memory, large numbers of elements, or each element is a large data item, I can have some efficiency issues, and adding elements to my vector might become an expensive operation. One way I can counteract that is by using reserve. The reserve function is going to allocate space inside my vector to hold elements. Now we're not creating elements, we're just changing the amount of space we have for the elements. And after I use the reserve function, if I then used capacity, capacity will tell me how many elements fit in the vector. Size tells me the number of elements actually in the vector. Now let's see an example of how we can use the reserve function with vectors and how it will impact capacity and size. I'm going to begin with an integer vector named values. And when I declare the vector, I'm going to assign 5 values to 5 elements. At this point, this vector has an array holding 5 elements. And if I want to add a 6th element to the vector, I can use the pushback function with the value I want to add in parentheses, but there's no space in this vector for a 6th value. What will happen is my vector will allocate a new array inside of itself that has space for 6 elements, and it will copy the first 5 elements into the new array and then release the memory for the old array. So I have a number of things going on just because I added a single element. Or I could use the reserve function. When I use the reserve function, I'm adding space to the array, I'm creating enough memory to hold an array here for 10 elements. I'm not actually creating 10 elements, I'm just adding enough memory to where I have the array so that I can store 10 elements. After I use reserve with 10, if I were then to ask the vector for its capacity, I would see that the vector's capacity is 10, but its size is still 6. I only have 6 elements in this vector, but I have space to store 10. So in this video, we first discussed how we can use multiple vectors to store related data. And then we saw some different ways we can modify a vector's size. We saw how the pushback function will add an element to the end of the vector. Resize will change the number of elements in the vector by either adding or eliminating elements. Reserve sets aside space for more elements. And we saw the difference in the size function and the capacity. Size tells us how many elements are in a vector, but capacity tells us how much space we have set for that vector and how many elements the vector can hold.